Final section on linear inequalities is going to be optimization problems. Now, optimization isn't necessarily something we think of all the time, but we do think of optimizing, and that's what the root of optimization comes from. So optimization is the act or is the action of making the best or most effective use of a situation or resource. Okay, and that could be money, time, product. In manufacturing is all about optimization, trying to, if it's even food stuff, it's all about optimization, trying to get the best or most effective of a situation or a resource. How do we come up with optimization stuff? Well, we follow the following steps. Number one is we identify what we are trying to maximize or minimize. Okay, so we're always trying to maximize or minimize. We could be thinking of like maximizing profit, minimizing distance, maximizing the harvest, minimizing cost, stuff along those lines. We're trying to figure out what are we going to maximize and what are we trying to minimize. Then we create an equation, okay, using variables from step 2, which we'll get through in a little bit, which we call our target equation. So we are going to deal with an equation, not an inequality, but we're going to deal with an equation which represents, let's say, the max profit, minimum distance, max harvest, or something along those lines. So we have to come up with an equation for that. Now, how we're going to do that is, or what we're going to kind of get to with this is our next steps here. So number 2 is we have to figure out what 2 things are causing this. So like profit, distance, whatever, to change. Okay, what are the 2 things that are causing it to change? Okay, if it's number of students? Well, it's the males and the females. If it is the profit, well, it is the things that we're selling. So there'll be 2 different things that we're trying to sell. We assign these 2 things to be our variables. Okay, so it's a little bit what we did through our last lesson when we were taking a look at how do we come up with inequalities and equations. We're going to be doing the same thing here. Now we're going to use those 2 variables to come up with our max-min problem here, max-min equation, but we're going to deal with inequalities as a part of that. Now, restrictions, okay, or parameters, okay, will be given, and we're going to create inequalities, okay, using x and y describing these restrictions. Okay, so whether it is that something has to be bigger than 0 or less than 0 or greater than 60 or less than 60 or whatever the case it is, okay, that's what we're going to do. We're going to come up with those parameters. We're going to create inequalities which represent that. Okay, and you're going to have a number of inequalities per question. Now, minimum number of inequalities you can have is at least 2. Often you're going to have between 3 and 5 inequalities which are going to represent the solution to that. Okay, we're going to take those parameters or inequalities from step 3, we're going to type them into Desmos, and we're going to identify the common area, which is our system solution. Okay, so we find the common area in our system solution. We identify the corners, okay, or edges of the common area. One of these points, okay, x, y values, is going to lead to our final answer, whether it's the maximum or the minimum that we're dealing with. So one of those points that we have is going to be our max or a min that we're looking for. All right, so number 6, next thing we do is we test each possible solution or our points from step 5 in our target equation, which means step 1, and then we pick the best answer. Now that answer is going to be either a max or a min. Okay, so it's going to depend on if we want to maximize this or if we want to minimize our solution here. Then on our final graph, what we're going to make sure is we label all of our information. We're going to label both axes as to what they are. We're going to define our variables. We're going to give our target equation, and then we're going to give a statement of our answer. Okay, this can be a sentence or two, which just explains what did we come up with? What was going to help us to maximize or minimize our final solution? Now for this last little part, this year what we're going to be doing here is I'm going to be asking you to come up with the values on Desmos, okay? Graph it out, paper, pencil, and then write in all of our information. Next year, when you get into grade 12, you're going to be doing some of this graphing as well, and all this will be then printed off and labeled. But for now, we're not going to do any of the printing. We're just going to draw them on graph paper, on graphs, and then label all those values as a part of that. But we can use Desmos to come up with our graphs.